Hello, class. My name is Teacher Sydney. Today we are going to learn about the reactivity series of metals. Now, when we talk about reactivity series of metals, here we are mainly looking at how we are able to arrange these metals based on their reactions with the other substances like water, even based on their reactions with the other compounds, or we talk about the displacement reaction. Now, this series is usually used when we want to predict how metals will react with other substances. In other words, metals which are higher in the activity series will displace those which are lower in the activity series. And so, when we look at the metals in our periodic table, we realize that group 1 metals are more reactive than group 2 and other subsequent groups. It means as you move across the group, the reactivity of metals begins to reduce. That's why the group 1 metals are more reactive than the group 2 metals. This is because of the reduction in a atomic radius, which means that as you move further away from group 1 across the period, the size of the atom begins to reduce and hence an increased nuclear attraction for the outermost electrons. And you're aware that for metals to react, they react by loss of electrons. So if the outermost electrons are tightly held by the nucleus, then the reactivity will reduce. Uh, when we go down a group, you realize that the reactivity of metals increases. This is because of the increased atomic radius, because of the energy levels which are being added. And consequently, the outermost electrons are loosely held by the nucleus and therefore are easily lost during a chemical reaction. And so we want to look at watch a video where we can be able to compare the reactivity of sodium, potassium, and lithium. So in this video, we want to compare the reactivity of these three metals, that is sodium, lithium, and water. And potassium with cold water. And so in our water, we have added litmus solution because we know when metals react with water, they give us an alkaline solution, a hydroxide, which is an alkaline solution. And so this will help us to be able to check the reaction and be able to make the observations critically. Now, as you watch this video, I want you to take keen observation. Here we are having a reaction between lithium and water because in the next slide, you are going to pause as you watch this video and also make some observations and then you answer the tasks which are assigned to you. And so here we have a reaction with sodium, which is the next one. How sodium reacts with water. Oh, you can see that kind of explosion. And then lastly, we have potassium with water. Take note, compare the rate at which it reacts. These three metals react, and then you can be able to arrange them in order of their reactivities. So we have an explosive kind of reaction here with potassium. So here potassium in slow motion, you can see the explosion which has taken place, bright colored. So pause this video a little bit and then you answer the tasks which follow. And here we have that state what was observed when each of the metals was reacted with water. State which of the metals is most reactive and least reactive with cold water. Arrange the metals in order of their decreasing reactivity. Now, I believe you are able to attempt this. Now, we want to compare this from my findings when we look at the order of the reactivity of those three metals. Uh, the observation I noted that lithium reacted slowly as compared to sodium, which reacted more vigorously than lithium, while potassium reacted very, very vigorously. So this puts potassium being the most reactive, followed by sodium, and then followed by lithium. Here is another reaction between tin, iron, magnesium, copper, and zinc with water. Please also pay attention to this. So we are reacting it with water so that we can also make these observations. And in our water, we are adding phenolphthalein so that we can be able to, an indicator, so that we can be able to make the observations. Because some of these reactions are very slow, it may be very difficult for us to see, but pay attention and observe. And you'll be able to also answer a similar question uh, regarding the observations which are being seen here. So we're going to pour water in each of the test tubes containing tin, containing iron, magnesium, copper, zinc, and calcium. So here we're adding water to tin and we observe the reaction. We're adding water to iron. We also wait to observe the reaction. Water to magnesium, we observe the reaction. To copper, we also wait to observe the reaction. Then to zinc, and then finally to calcium. Likewise, compare the reactivity. So we can see immediate change of color in calcium. Immediate change in color in calcium. Observe that reaction. And so you compare which one is most reactive among these metals and which one is the least reactive. It may be difficult to get the least reactive here, but you may be able to get the most reactive, or you may be able to identify the most reactive and other metals which do react. Because there are some of these metals which do not react with cold water, they do react with steam when the conditions change. And so you can be able to see these observations with calcium, with zinc, with copper, magnesium, iron, and eventually tin. So when you look at them one by one, we see there is some color change here in magnesium. There's some color change in magnesium, but we don't see color changes in zinc. We don't see color changes in copper, in iron, and also in tin. So a simple task for you: state what was observed when each of the metals was reacted with water. State which of the metals is most reactive and least reactive with cold water, and arrange these metals in order of their decreasing uh, reactivity. Sorry, arrange the metals in order of their decreasing reactivity. And so, similar task. So now, when we look at the overall reactivity series, we will see that potassium is the most reactive, while gold is the least reactive. We have arranged them in order of decreasing reactivity as you move down. Potassium having the highest reactivity, followed by sodium, lithium. They are very reactive generally. Calcium, magnesium, aluminum, they are quite reactive. Tin, lead, copper, they are not so reactive, while silver and gold are completely unreactive. Thank you for listening. If you have questions, please feel free to send me an email and then your questions will be addressed. Thank you.